Hi everybody, we're back for part 3 of the biomodeling assignment. It asks us, we're on the last page just before, or second last page just before question number 8. It asks us to go to amino acids. Now I want you to read through this material over here, over on the right hand side. You can pause this so that you can read through it. One of the things that I want to point out to you is that at physiological pH, that's the pH of our bodies, the amino group is protonated, which means it gets a proton, and the carboxyl group is not. So they're going to show them as NH3+, and the carboxyl group, instead of being shown as COOH, it's going to be shown as COO-. This isn't a really big deal, and you don't have to understand why, but just know that when they're showing it to us, normally we think of it as being an NH2, and the carboxyl as being a COOH. They're going to be showing them a little bit differently over here. You can see that they've got like an extra minus and they've got an extra plus with an extra hydrogen. Just know that this group here is the amino group and this group here is the carboxyl group. This green part is showing the central carbon, or as they're referring to it, the alpha carbon, and the hydrogens are all the white ones. This big pink part over here is the R group, which means the rest of the group. And we're going to look at some different ones here. So I think that I've just shown you a whole bunch of things that are there. We're going to click on nonpolar aliphatic acids, and we're going to use the ball and stick, and we're going to bring up the image for glycine. So this is the ball and stick image, and here's glycine. So remember that we have the blue is representing nitrogen, and the red is representing oxygen, gray is carbon, white is hydrogen. So you can see that we've got different parts of this amino acid. And it asks you what the new color blue is representing. Well, I just told you, and it's right over here showing you what the color scheme is. Glycine is the simplest amino acid with the required amino group, carboxyl group, and alpha carbon with its associated hydrogen. And then it says determine what single atom forms the rest of this amino acid. There's our carboxyl group, our amino group, our carbon and its associated hydrogen. What atom is representing the rest? All right, now let's bring up alanine. And here's alanine, and I'm going to turn it like this and bring it down. There we go. So here we've got our carboxyl group, our amino group, our central carbon, its associated hydrogen, and then it's asking, what is the R group? So that's the R group up there. What is that R group? So you can put down the chemical formula for that. And let's click on each of the remaining amino acids in this group. All right, there again, amino group, carboxyl group. Look at the atoms in that R group. We'll look at leucine, amino group, carboxyl group, central carbon, and then look at all of these atoms. We'll look at isoleucine, amino group, carboxyl group, central carbon. Look at those atoms. And proline. Again, we've got our amino group, and our amino group is here, our carboxyl group, our central carbon that holds them together, and then look what happened with our R group there. Okay. Here's our amino group, our carboxyl group, central carbon, and then there's our R group. All right, so you're going to answer some questions there. And we're going to go to question number 9. It says go back to the amino acids. Again, feel free to pause this at any time if you need to stop and write stuff down. We're going to click on the aromatic amino acids, and we're going to look at the ball and stick models of all of these. Here's phenylalanine. All right, so again, amino group, carboxyl group, central carbon, and then there's the R group here. Let's look at tyrosine, amino group, carboxyl group. Look at the R group here. And tryptophan, amino group, carboxyl group, and R groups. So it's asking you to notice, it says, look at the ball and stick models of all three. You have to write down now at the bottom of this page, explain how the R groups of these amino acids are the same as the nonpolar aliphatic group that you looked at in the last question, and different from the nonpolar aliphatic group that you looked at in the last question. So you can pause this and write your answers down. For question number 10, we're going to go back to the amino acids frame, and we're going to look at the polar uncharged amino acids. There's a bunch of them here. We're going to look at the representatives of this group, and you're going to look and see what the R groups have that is different from the previous two. You may want to take a look right down here about what the legend is here for the colors. So here's serine. Maybe. There it is. There's serine. Amino group, carboxyl group, R group. Threonine. Cysteine. Methionine. Asparagine. That's your amino group, and that's your carboxyl group, just so you know. This part here is your R group. And glutamine. Here you go again. So you're going to write down what they all have that is different from the previous two. Now we're going to go back to the main index, and we're going to click on peptides. And you can read this section here. Again, feel free to pause this recording so that you can read it all. Question 11 says, one peptide bond joins two adjacent amino acids. What parts of adjacent amino acids interact to form this bond? So you can look at these amino acids here. Here's an amino group. Here's a carboxyl, or here, this was a carboxyl group. Here's the amino group of that one, the carboxyl group of that one. Here's the amino group, the central carbon, carboxyl group. So tell us from which, the amino acid on the left, what part of it is bonding to the next one, and the amino acid on the right, what part of it is bonding to the next one. And then what is released or removed as this reaction occurs based on the information given. So here is an example. All right. That's what they would look like once they were all bonded together. All right, we're going to go back to the index, and we're going to click on the alpha helix. Because some amino acids, once they join together, their backbone will start to twist and form a helix. So we're going to look at these views of a peptide chain of amino acids. Here it is. Wow, that's pretty cool. And we're going to look, if we look at just a line that represents the alpha carbons, so we're not looking at all of the extra stuff. All right. Let's show again the bonds in the backbone, but we're going to hide the side chains. So you can see that that's a bit of a coil there. And now let's show, all right, you can describe the alpha helix. It's stabilized by hydrogen bonds. Remember we talked about those where we've got kind of negative region of one and the kind of positive region of another, and they're attracted to each other, so they kind of hold things still. And then we're going to look at the axial view. It says especially after viewing the axial view with the side chains. So we're going to throw on the side chains. Take a look at this. Where are the side chains? So I'm going to take the side chains off. All right, I'm going to actually just do this line, and I don't know if I can do this now. Yeah, there we go. Where are the side chains? And that's what that last question asks, in relation to the backbones of the amino acids. So there's this image, but it's a little easier to see if we look at it from here. All right, that's it. So by the time you've gone through this and paused it where you needed to, hopefully you've been able to finish the whole biomodeling assignment, and you'll be able to hand those in when and if we finally see each other again when this weather all comes back to normal. Have a great day, stay warm, and we'll see you in class.